Hi there and welcome to this brief session on how to use Jamovi for research methods and statistics. My name is Dr. Thomas Rhys-Evans. I'm an Associate Professor in Occupational Psychology at the University of Greenwich, and you can follow what I do at Thomas Rhys-Evans on Twitter. So, a brief introduction, just to note that this session is for individuals who are familiar with research methods, have some understanding, but not necessarily familiar with Jamovi as a software. So we will rely upon you having some basic understanding so you can follow what we're doing. And the idea here is, for the first few slides, you might want to have a look at the screen I'm sharing, but afterwards, I'm hoping I will be mostly in audio mode, and you'll just be able to follow what I'm doing through your screen. And if you ever need to clarify, I will obviously demonstrate on my own screen at the same time. So this is designed to be a practical session. It was delivered at my own university across roughly 90 minutes. So I will take a couple of breaks in between to give you points to explore and do activities. So let's get started. The first kind of question to address is, why should I consider using Jamovi? Now, there are obviously a number of statistical software packages available for use within psychology, my own field. SPSS is certainly one of the most common. My concerns around this are predominantly based upon the fact that it is proprietary software. So often what we do is we give our students and give our colleagues skills and experience with a certain package which they can then no longer use after they graduate. So I have ambitions that we can perhaps focus on open source software where anybody can access it, and indeed you can share resources with your collaborators very easily. So based on the initial kind of introduction book that accompanies Jamovi, the purpose was defined as a free and open statistical platform which is intuitive to use and can provide the latest developments in statistical methodology. And this is, I think, probably a fair summary. It is incredibly accessible, intuitive to use, and there are a lot of new developments in research methods and statistics which are captured within the modules, which aren't necessarily represented in other statistical software. So just a brief introduction to some kind of different ideas around it. So Jamovi is based upon R, which is obviously incredibly vast and complex, whereas Jamovi is a little bit more simpler. And the value of being based in R, I see, is that there are a variety of modules which you can add to Jamovi, which increases the scope of possible functions. So it taps into the kind of broader capacity for R to do incredible and amazing things. The other key feature is that it has live data management, so the results are updated as and when you change things. So if you think perhaps I want to have a look at a different dependent variable, you just switch the variables and it instantly does it and corrects the results for you. And finally, something I find very valuable is that it saves data and your analysis outputs together in one file. So that means there is always a kind of permanent record of what you've done and what's happened. And that's super useful too. So let's get started. To get started, all you need to do is download Jamovi because it's open source software. Anybody can download it completely free. You can see it is jamovi.org/download.html. And if you haven't yet downloaded it, please do pause me and come back to me when you are ready to go. I tend to encourage people to go for the kind of solid version rather than the current version, because if there are any niggles or bugs, sometimes they can be found in the current version. So I encourage you to do that. And then we'll get started. So just a very kind of brief introduction as to what you're going to see. So this is the interface. So you'll find basically two great columns on your screen. On the left-hand side, this is your data view. So this is essentially an Excel or SPSS data view spreadsheet where you will be able to either copy and paste or import data. So very, very simple to see. And if you double click on any of the column headings, you can click around and see all sorts of information relating to that variable. On the right-hand side, this is where you will see all your results or outputs. And it's very similar, if anybody uses SPSS already, to a .sav file. So it's, in essence, your outputs. And the value is, you can see both at the same time, and depending on what you can do, you can move the barrier in the middle, so you see more or less of the data or the analyses. So that's the basics. There are other things to note. So firstly, in the top left-hand side, you'll see typically three things: data, analyses, and edit. And so these are some of the core options. So obviously, if you want to pick an analysis to run, you pick analyses. If you want to edit some of the information on the right-hand side panel, edit function is good there. And the data panel is good for when you are trying to, for example, transform variables, which we will do very, very briefly. So you can see when you click analyses, the top banner provides you with a range of different analysis kind of groups or families, and these are called modules. So you might not have all of the ones I've listed. That's absolutely fine. We're going to add a few to your list today, and you can see that they are pretty clear and obvious in terms of how they've been labelled. So you can see that we have exploration, t-tests, ANOVA, regression, for example, which capture several of the kind of basic research methods tools. On the right hand side, just under the blue banner, you'll see a plus sign, and this is where you can click to add new modules to Jamovi. And so we're going to do this very shortly, and this is what I was referring to previously in terms of increasing the scope of what's possible when using Jamovi. So that is all you're going to need to know. So we're going to get started. And I wanted to give you a bit of a real-world experience, and so I'm going to share with you what I've been doing with my undergraduate psychology students as part of a recent group dissertation project. And our ambition was to use Jamovi as the kind of statistical analysis platform to analyse the replication of FAT and K from 2008. So FAT and K conducted 9 studies with nearly 2,000 participants in total, looking at how perceptions of corruption were associated with hierarchical structures of organisations. The belief being that a taller or a higher organisational structure where there are lots of levels of management, there's perhaps greater emphasis on competition and status, and thus it might lead to greater corruption, and thus people's perceptions of corruption. And so what we're going to do is we're going to, so my students replicated studies 1C and 6, but we're going to tackle the more complex one. We're going to tackle study 6. What happens here is, in the original study, they asked 103 people from a farmer's market, and they asked them to read a fact sheet of the local county's finance department, manipulating the structure. So on the top right, we have here a hierarchical approach. So it's a high hierarchy where you can see clear levels of management. And in the bottom, you can see a less hierarchical or more flat organisational structure. And participants answered a variety of questions, including some on their perceptions of corruption associated with each of those different hierarchies, and whether they would sign the petition to instigate such an audit. So, rather, there was an ethics audit. So some of the key questions were, do we need an ethics audit? And then they were asked, would they sign the petition? And the hypotheses associated with this were that taller organisational structures would be perceived to be more corrupt, and that corruption would be a mediator between organisational structure and trust-related behaviour. That is, you have a taller hierarchical structure that leads people to think that it's more corrupt. If people think it's more corrupt, they're more likely to then sign the petition to say, we're not happy with the ethical standards of the organisation. So that's the proposed kind of hypotheses and approach. And this is what we ran as a group to try and replicate. Obviously, we, during COVID times, didn't have the ability to go and crash several farmers' markets. So instead, we created a hypothetical business called Greenwich Business Liaison. and GBL for short. And they, again, were provided a fact sheet that was very similar around the finance department and were asked to complete practically the exact same materials as the original study. So the first thing we could perhaps consider if we're doing a replication study is, what number of participants do we need? What should we target? And so often a lot of studies get criticised based on sample size. So we can see here the previous study had 103, which is obviously not massive. But when people critique sample size, it's often actually not sample size they're critiquing. It's often they're critiquing the power of the study. So power is the chance of detecting an effect that exists. And when we have low power, it increases the likelihood that we're going to make some sort of erroneous conclusion from the analysis. And so we're going to do a bit of power analysis. This is on the basis that if we have 3 of the 4 pieces of information listed, we can make an estimate of the 4th. We can make a guess. So in this case, we want to know number 3, sample size. So as long as we know our alpha, beta, and effect size, then we can calculate or kind of estimate what sample size would be necessary. So our alpha here is our false positive cutoff, often kind of considered your p-value cutoff, so typically 0.05. Our beta is our acceptance of false negatives. Now false negatives are seen to be 4 times less bad than false positives, so 0.05 times by 4 is 0.2 or 80%. So typically we try and aim for 80% power. With these days, we're encouraging researchers and journals to push standards a bit higher and go for 90% power. So it's 0.1. And we want to know our effects, and we need to know our effect size. Typically, we target what's known as the seesaw, which is our smallest effect size of interest. So in essence, we want to find the smallest effect we can in the previous literature and then power ourselves so we, regardless of, if the effect is small, we'll be able to have sufficient power to be able to detect it. So we always pick the smallest effect size we can. So this is what we're going to do through Jamovi. This is the first thing we're going to try and attempt to do. So we've got an example here of text from the original study from Pfaff and Kay, and we can see here that our Cohen's d, which is our effect size, so effect size, for those who want a brief recap, is the size of the effect that we're interested in. So the size of relationship, so is it really strong, is it very weak, or the size of difference between groups. My classic go-to example here is understanding or knowledge of period pain. If we were to compare men and women, we might expect that there would be a very, very big difference in men and women's understanding of period pain, in which case we probably don't need that many participants to be able to detect such a large effect. Whereas the difference between men and women in crossword ability is probably tiny or non-existent. So to try and differentiate values on that distribution, which are highly overlapping, we'd need a very, very large amount of participants. So Cohen's d of 0.48 is a modest medium-sized effect. So we should try and kind of calculate how many participants do we need to be able to find that sort of size effect. And the way we do that is through a module on Jamovi called JPower. So one of my friends and collaborators, James Bartlett, has written a lovely guide of how to do power analysis through Jamovi. So that will be in the resources at the end of this presentation. And if we load up Jamovi, so this is what you should have. So what you do is you go to Add New Module on the top right hand side, and so here you probably haven't already done it, so you just need to click here, Jamovi library, and it will be the third one down, JPower. I've already installed it, and you can see it's up here, and it looks a little bit like this, so 2 overlapping distributions on there. So all we need to do is click on that, and then we question what type of analysis are we going to be doing. Well, if we're trying to look at the difference in mean scores between two groups, and these are independent groups, so each participant was randomly allocated to a group rather than completing both conditions, then we have an independent samples t-test. Now, as you can see, you've got lots of things you can edit on this left-hand side, and then you've got the outputs on the right-hand side. So people who are now following me just by audio, we've clicked J-Power, and we've chosen t-tests and independent samples t-test. And so you first get asked, what would you like to do? And our key kind of point of information here is to calculate n per group. We want to calculate how many participants we need in each group to be able to detect our, to confidently detect our effect. Obviously, we can also calculate power and effect size and things like that, should we want to. But we're going for this. So, starting at the bottom of the different boxes and options, you can choose for a one-tailed or two-tailed test. In this case, we're going to be open to exploring different possibilities, and that the original results might be erroneous, so we're going to go for two tails. Our alpha, or our type 1 error rate, we're going to stick with the conventional 0.05, which is what we'll consider our kind of cutoff for statistical significance. The next box up, relative size of group 2 to group 1. We have no reason to suggest that there will be unequal groups or unequal numbers across groups, so we're happy to keep that as 1 to 1. So that means we expect them to be roughly equal. And our minimum desired power, so we're going to take the highest standards of modern science and accept 90% power as a minimum. And then the only thing we need to really change is our effect size. So here we're looking at Cohen's d. And as you can see in the original study, we found a Cohen's d of 0.48. So we just very briefly changed to 0.5, which is the automatic, to 0.48. And you can see here on the right-hand side, it will tell you that you need 93 participants for each group to be able to detect an effect of 0.48 with 90% power and an alpha of 0.05. So that's fantastic. So we need 186 participants in total, so 93 per group, to be able to detect that size of effect. Now, jamovi here has been very kind to you. It's also got a variety of other kind of sources of information. So you can see you've got powered visually represented here, so you can see what would happen if we had a higher effect size or a different number of sample size. And you can see the power curve here by number of participants, and you can play around with the variety of options. So there's kind of a power demonstration here as well, so you can visualize all sorts of things. And what I particularly like is all the associated information. So if you read through the supporting text, that can actually be really super useful to double check your understanding of power analysis if you're a bit thrown by my own, and have a go at seeing what would happen if you change the sample size or the power level or the whatever. So that's where we've got to. I'm just going to get rid of some of that to decrease our text. So there we are. Before we've even had a look at any data, we've been able to run a power analysis using jamovi, which is fantastic. So what we now know is we need about 186 participants. Unfortunately, that's already been collected for you. So this was a project run by my students here noted. They did a fantastic job. We even pre-registered this research using a jamovi file as a way of showing what analyses we'd run with the different data sets, because we ran study 1C and 6. So props to them, congratulations. And what I've presented alongside this video and the slides is the data for us to have a run through with. So we should first show you how to get the data into our jamovi file. So the way I like to do it is to click the 3 stacked lines at the top left in blue, and then import. And so you can import a variety of different file types. I'm obviously going to look through my dreadful list of different folders and open the file I've called training data. I'm going to get rid of these other columns that we don't need. And what you'll be able to see if we maximize the extent, you can see here we have got a variety of variables. So we started off with an Excel file, and it is very cleverly recognized that the top line is the headings or the titles of the variables. And so we've got a variety of different things we've captured here. So we've got the time it's taken to complete as the first variable, the condition as the second, so whether they were in the high hierarchy or low hierarchy condition, and then a variety of responses to questions. And then finally at the end, the last two variables are age and sex. So if you want to double check and clarify, you can see that I've labelled them hopefully as clearly as possible as a separate file. So for 1 is male, 2 is female, and 3 is for doesn't want to be identified as either. So that is our data. And hopefully you follow that 3 top lines on the top left, import, and then find wherever you've saved your data file and open it up. And that's as easy as it gets. So one of the first things we should probably do with our data file, given we've now eyeballed it and we can see there's roughly 225 participants, and we've got a variety of different measures. The first thing we should ask is, have we met our power analysis target? Which, if you remember, or in fact don't even have to remember, just have a look at the right-hand side of your screen, is 93 participants per group. So the easiest way to do this, and one of my favourite things to encourage everybody to do, is always look closely at your data in terms of exploration and looking at descriptive statistics and visualizations. So that's exactly what we're going to do for this kind of next few minutes. So we want to go on our exploration module, which is the first option, and we're going to ask for descriptive statistics. So for those following by my voice, we're going for analyses and the top bar, exploration, descriptives. And then for anybody who's had experience with any other statistical packages or softwares, you will probably find that this is incredibly intuitive and familiar. So all you have to do is pick what you want to do. So in this case, what we're going to do is copy our condition variable, which is obviously high or low, into our variables box. And then all we're going to do is ask underneath that, so you can either click on the thing you want and drag it across, or you just highlight it and click on the arrow to push it across. And we're going to ask for frequency tables, which is the first immediate thing that happens under your list of variables. And you'll see it happily appears on the right-hand side for you. And we can see here that there were 118 participants in our high hierarchy condition and 107 participants in our low hierarchy condition. So, hooray! My wonderful students collected enough data to test or to have sufficient power to explore our hypothesis. Now, obviously, this was just for hypothesis 1, which was around the simple difference between high and low on perceived corruption, not on the more complex mediation. But there we are. Good enough for me for now. So hopefully you can see here you can play around with all sorts of options. You can ask for different types of statistics if you'd like them. So mean, mode, variance, range, that sort of thing. We can also have a look at skew and kurtosis and normality, and you can also plot a variety of different things. And we'll come back to some of these options very shortly. So first of all, we've agreed that we've met our sample size targets for our power analysis. So next, we can probably do another thing to kind of test out some of these exploratory functions, which is let's have a look at if participants completed our study in a timely manner. So if you want to carry on, you can click on the analyses you just did on the right-hand side and change which variables you're selecting. Or if you want to keep our frequency data, all you have to do is make sure that you're not clicking on it. So you just push the arrow to push it back into its place, and then start again on the top left-hand side, exploration. And what we're going to do again is ask for descriptive statistics, and we're going to move the seconds to complete variable to our variable box. And so you can see the descriptive statistics on the right-hand side of your page. And so you'll be able to see, for example, a confirmation that we do indeed have 225 participants. And you can see the mean and median time to complete the study, which was ranging from 79 to 521,000. I believe this is seconds we're talking about. This was a fairly brief study. And then to visualize this, it's very simple. We're just going to go down to plots and we'll ask for a histogram. And so be able to see, because the numbers are so big, it looks slightly distorted, but you'll be able to see that the vast majority of participants completed study in a very short, reasonable amount of time. And then there were a few people who clearly opened the study, started, got distracted by something, came back to it. We didn't pre-register exclusion of any of these participants, so we're not going to worry about it, but just something to think about, something to consider for future. Okay, so we've got our information upon speed of completion, which might tell us some useful information. Let's have another check. Let's find out something. So we provided participants with information on a very made-up hypothetical organisation, Greenwich Business Liaison, which was one of the only combinations of words around business and consultancy which wasn't already actually a real business. So we did check. Very thorough. However, we did ask participants, do you know anybody who works for this organisation? So this might be a useful attention or engagement check, because clearly if they say they do know somebody working for Greenwich Business Liaison, it's impossible. They can't be. So, unless somebody likes the name enough, saw it in this presentation and then started an organisation, in which case, good for you. So we might suggest that it would be useful to know how many participants claimed they knew somebody working for GBL. In which case, again, we go back to explore and descriptive. So analyses, top left, analyses, exploration, descriptives. And we move the fourth variable across, which is know anyone working for GBL. And we move that across to the right-hand side. And again, the variable name tells you that 1 is yes and 2 is no. So we're hoping that all of our participants will be no. So let's have a look for our frequency tables, which will tell us the breakdown. And you can see on your right-hand side of the screen. So you have your frequencies table. And we see that 211 of our participants claim they do not know anybody working for this organisation. However, 14 participants did. Oh dear. Probably problematic, but again, we didn't pre-register this as an exclusion criteria, so this is just good to know. This is something to acknowledge that we might want to be cautious about, and nothing too much to worry about there. So hopefully you can see there are lots of options for plots and statistics and things, which are incredibly useful. Now, if you're wanting to take some of this information and provide it in a journal article or something like that, it's very easy. You just right-click. What you can then do is export or copy, and it will very usefully be in a super helpful format to plonk straight into, for example, a Word document or otherwise. So that can be really useful, and particularly with the visualizations as well, because they can be quite nifty. You can again right-click and you can export them or save them as that. Now, at any point you're worried things might go wrong, obviously feel free to save the file. So as I noted previously, Jamovi will save the data and all the analyses you have done together, so there will be a permanent record of everything you've done. So you just have to click on the 3 stacked lines and save, and that will save everything together for you. Okay, so we've done some checks. I feel like that has gone pretty well. We found out there's probably a few dodgy responses potentially, but nevertheless, we're gonna move on. Now, one of the starting points to starting to address our hypotheses is to acknowledge how we measured corruption or perceptions of corruption. So we asked participants the same 3 questions of the FAT and K, which essentially asked, do you think people who work for this organisation are corrupt? Do you think there are opportunities for them to do unethical and corrupt behaviours? And so what we have is three variables, which are corruption underscore Q1, Q2, and Q3. Now, it's probably useful for us to work out the internal reliability of this, to work out, do people respond similarly on one item to the next item, and to various combinations. So what we want to do here is a factor analysis. Depending on your setup, some people might have factor already at the top in the main key analysis bar. Some may need to add modules. So if you do need to install it, feel free to click modules on the top right, the square, and again go to the jamovi library. I'm imagining, based on the setup, most of you will already have it. And when you click on it, you'll be offered a number of different things. So we need to clarify what we're interested in. Are we interested in scale analysis, or are we interested in data reduction, aka things like factor analysis? This is very, very intuitive, and I'll give you a preview very shortly. But we're going to go for reliability analysis first. So click that. And again, you'll be asked to move some variables across. Now, when I do my teaching, often a lot of my students are quite surprised that there are alternatives to Cronbach's alpha. That isn't the be-all and end-all for internal reliability, given that in the vast majority of, certainly a vast majority of psychology papers who've done this sort of, any sort of scale-type work, Cronbach's alpha will be the one they report. There are a variety of different ways to calculate internal reliability. McDonald's omega has become a lot more popular very recently as we've kind of renewed our attention on kind of improving our scientific practices. So we're going to ask for that as well. So we're going to, under scale statistics, we want Cronbach's alpha and McDonald's omega, which looks like a funny W. And what we're going to do is copy across all three of those corruption items. So corruption underscore Q1, Q2, and Q3. And you'll see immediately on the right-hand side, it's come up here and told us that it has, the three items have a Cronbach's alpha of 0.79 and a McDonald's omega of 0.818. Now, if you want a little bit more precision, you want more numbers for the same analysis, on the top right-hand side, there's three white dots on the blue banner. And if you click on that, you can have, for example, you can clarify how many decimal places or significant figures you want information to be presented in for numbers and p-values and things like that. I can't say I'm very interested in that. I think that can give you false perceptions of clarity and confidence, where actually we should always look at kind of estimates and ranges. However, if you want that information, that is there. And obviously, if you want information around the mean and standard deviation of our perceived corruption, you can click those boxes, and you'll be able to see that the corruption items have a mean score of 4.35, which is on a scale of 1 to 7, modest, and a standard deviation of 1.27. So it shows there is some variability. And some of my favourite things to do here is to look at the additional options and ask for a correlation heat map. And this will tell you how strongly each item is correlated to each item. Now, this can be useful for a variety of different reasons. One of the core ones is that, for example, you might have forgotten to reverse score some items, and in which case, if the correlation is negative, you might suggest that either you haven't reverse scored, or perhaps you've got a number of scales or kind of factors within your questions, and you might need to do some other analyses. In this case, we can see here that the correlation between question 1 and question 2 is 0.69, but the correlation is weakest between questions 1 and 3, where the relationship is 0.43. As a whole, these analyses tell us, particularly the internal reliability estimates, they tell us that people respond similarly to questions 1, to questions 2 and 3, and the variety of iterations. Indeed, we can visually look at that when we have a look at our data, and you can see, for example, the first participant has scored 7 in all of them, the second has scored 4 in all of them. When we go back to our analysis, if you do realise you have reverse scored them, if you don't want to go through the faff of recoding the variable, you can just copy across, and you'll be able to see, for example, if I copy across question 2 and pretend that that was reverse scored, that has all of a sudden made our Cronbach's alpha and our McDonald's omega completely problematic, and you can see here the heat map suggests the correlation is in the opposite direction. So it's always good to visualize and have this kind of reminder to see it visually. So there we are. And that's as easy as internal reliability gets. Very, very simple, and hopefully quite intuitive to do. So given that we've found we have relatively high or acceptable levels of internal reliability, the first thing we should probably do is create a total score of these three items. Okay, so often analyses work based on total scores rather than individual items. So we should probably attempt to make a total score. Probably seems like a good idea. So let's get data in full view. And then what we're going to do is go to the Data tab on the top left-hand banner. And so what we're going to want to do is we're going to compute a new variable. And we're going to call it corruption underscore total. So that's very clear, we're making a corruption total score. And then we can use a variety of different kind of equations or otherwise to calculate that. So one of the easiest ways is if you click the FX kind of formula box and scroll down in the functions, you'll be able to see mean. And so all you have to do is double click on mean, and then within that, and then you can, under the variable section, double click corruption Q1, comma, between each of them, and corruption 3. And then you'll be able to see, for example, in this new variable, which is called corruption total, that there is the mean score. And you can double check this. For example, participant 3. So if we add up their scores, so 6, 5 and 1 is 12, divided by 3 is 4. And indeed, the mean score here for our new corruption variable is 4. And you'll see that Jamovi is remembering how you're calculating this, so that's great. So if you want to change the way you calculate your scores, you don't want mean, you want to just add them all up, you can do that here. Another way of calculating this corruption score is, again, if you compute, give it another title. So in this case, I'm going to call it corruption total 2. You can do the typical equations that you would use in our SPSS syntax or Excel. So I'm going to open brackets. We're going to go for corruption Q1 plus corruption Q2 plus corruption underscore Q3. And the important thing to note here is that whether things are uppercase or lowercase doesn't matter. So if you've capitalized things, do ensure you remember to do so, because otherwise it goes a little bit skew-if. And so what we're going to do is we're going to add up question 1, question 2 and question 3 and then divide by 3. And if we do so, and I've done it all correctly, again it should be able to show you the exact same thing, and you can double check each of those different calculations. You can see here that they are in fact identical. So that's great. If you made a mistake, don't worry. All you need to do is right hand click on the variable that you're interested in the top. So in this case, I'm going to get rid of corruption total 2 because I don't need it. So you right click on the header and you delete variable, and it's gone forever. Now, the astute folk amongst us will notice that there is a very subtle but nevertheless observable change in the shade of box where you manipulate anything. So if anything is calculated or been actioned or manipulated, you'll be able to see that it comes up with a slightly different colour shading in the background. And that, again, is a useful piece of information to remind us that that has been manipulated, calculated, computed, transformed, or otherwise. Okay, so you see this data tab at the top left has got lots of other functions and things, for example, adding filters or computing new variables. So that can be super useful if you're doing a little bit of data management in Jamovi rather than just analysis. So what we now going to move on to, now we've got our total scores, we can start looking at our analyses. I'm going to tackle hypothesis 1 first. So hypothesis 1 is that organisations with a higher organisational structure will be associated with more corruption or perceived corruption than those in a flatter organisational structure. So the first thing we should do, and we should always do this, is to visualise the data as much as possible before we do any analyses. So in the top blue bar, we want to click Analyses, Exploration and Descriptives. So we want to, all we're doing is exploring the visualisation of the data. Now hopefully you've followed me thus far, and so you understand that we want to know our corruption, perceptions of corruption as our dependent variable. So we'll move that to our variables box. And we've got condition, which is our group variable. So if we move condition across to our split by, what it will tell us, and you'll see this on the descriptives box that appears on the right hand side, a variety of information based on the different groups. So for example, we can see our mean corruption score for our high condition is 4.61, and that's higher than the mean perceived corruption score for our low hierarchy condition, which is 4.07. So this suggests there might be some difference of interest. Let's visualise it, let's have a look at it. So what you need to do is you scroll on the left hand side in the descriptives panel to plots, and I like to, under box plots, everything. We want to see it all, and you can do this one by one to see how things change. So you start off with a simple box plot. You can see here you've got your scores, so your median and your intervals. You turn it into a violin plot, and you can see the distribution of the scores as well as the information provided in the box plot. You add your data, and that tells us it's slightly jittered so things don't overlap and it looks a little bit easier to see, but again it shows us the distribution of scores and can often point us to any outliers. And then we ask for our mean on top of that as well, which adds a little square. And so the total of this is a quite attractive looking figure. I think it's quite detailed and really useful. Provides the same amount of information a bar chart would, because you can see it would just go to that line and there'd be 2 bars. But it also shows you the distribution and how data is spread across the 7-point Likert. And so this visualization tells us there might be some modest difference in perceived corruption between high hierarchy and low hierarchy. It's certainly not massive, but it is something modest. So we should probably now run the analyses. So for those who have been playing along, you can probably guess where I'm going with this one. Analyses at the top. And we're going to this time run a t-test. Because we randomly allocated participants to the high and low conditions, in which case it's an independent samples t-test, because we have a between group design. And just as we have done with the exploratory stuff, we've got condition as our grouping variable and corruption total as our dependent variable. And you can see here the analysis is already plopped onto the right hand side of the page. You can see our t-value is 3.27. We have 223 degrees of freedom, which is obviously 225, our sample size, minus the number of groups we have, so 2, so it's 2 to 3. And we have our p-value, which is 0.001. So in the very traditional statistical way, we'd say this is statistically significant. If we are not confident that we have met our assumptions, we can ask for things like a Mann-Whitney U-test, and you can see there it will provide the information necessary. What I'm particularly interested and keen for everybody to use is the effect sizes, because I think that tells us much more information. And you remember that the original effect size of this was 0.48, and so if we ask for effect sizes, it will add a column, a line for Cohen's d, and our Cohen's d here is 0.437. So that tells us that the effect is quite close to or the size of effect that we've observed is quite similar to the one that was reported by the original study, which provides corroboration for their evidence. And we can ask for confidence intervals around these as well. And you can see the confidence intervals are very wide, and they do include 0.48. So many would consider that a successful replication, if you want to consider it that way. Obviously, lots to negotiate around that. The other thing we want to do here is also look at our assumptions. We obviously jumped straight into analyses, which is very naughty of me. Apologies. It's good to get to the output, but what we actually really importantly need to look at is our assumptions. So under assumptions checks on the left hand side, I click everything. So we want our homogeneity, normality, and QQ plots, and so we get given then some useful information. So the first one is our normality test. So what is the distribution of scores? Is it close to a normal distribution? And we have here a p-value for our Shapiro-Wilk test of 0.183. So typically we accept that any deviation from a normal distribution will be statistically significant, aka 0.05 or lower. In this case it's higher, so we're going to say that our distribution is normal enough. We then might want to take a little closer attention to our homogeneity of variance. That is, are the distribution of scores similar between the different groups? And we can see here again, if they were similar, we'd have a p-value less than 0.05, or at least that's a traditionally accepted cutoff point. And we can see here it is not. So we suggest they are roughly similar distributions, and we can see that here they're roughly similar. They're relatively normal and roughly similar. Finally, we then look at our residuals, and we're interested in how closely they map onto this straight line, and you can see they are pretty close. And altogether, all of these pieces of information give me confidence, or give me the suggestion that probably a normal t-test is fine, rather than a Mann-Whitney U, and so it would be fine to report this t-test as it was, with a 0.437 effect size. So, excellent. Now, if you could just save your data file and send it to all my students who'll be grateful for you doing their analysis for them, that'd be great. I think we can go a little bit further, and I want to show you some other things that jamovi can do. So, first of all, what I want to do is to encourage you to stop and check your understanding. So, we're going to do this through one of the other variables that I have provided for you. So, we asked participants a control question to check that they engaged with the information that we provided them around the fake business. And in particular, we at several points said it is a hierarchical, or it isn't a hierarchical organisation, and obviously provided the diagram which illustrated that. We asked participants essentially, to what extent do you believe this organisation is hierarchical? And they responded on a 7-point Likert style scale. And we want to see whether our manipulation worked. Did people engage with the information enough to detect or to report that there were differences? So what I would love you to do is pause the video and try and attempt to run this analysis and visualize that difference. Do participants who are in the high hierarchy condition report engaging or reading about a more hierarchical business than those in the flatter organizational structure? For those who need a few suggestion points and notes, the variables of interest are condition, which is obviously our second variable, and our control underscore hierarchy variable, which is our fifth variable, and you can see it is on a 7-point Likert. So I'll give you a second just to pause the video, go and have a play around and see if you can see whether there are condition-based, group-based differences on this outcome. Thanks for rejoining me. Now, there were two ways you could have done that. The first is to go straight back into t-tests, independent sample t-tests, and instead of, so we still have, we don't have corruption as our total variable, we have control hierarchy instead, and we have our condition variable over here, and so I will very briefly show you that the results here again showed a statistically significant difference of around 0.7 in terms of Cohen's d, which is good. It's stronger than the effect or the difference noted, and you can play around with that in other ways too. Or if I'm to get rid of this and claim that we never did that, you could have also, however, gone back into the analysis above where we did look at the corruption total and just bounce in control hierarchy instead of that. So again, same sort of information, but different ways of doing it, both equally absolutely fine. No problem there whatsoever. Okay, so if I get rid of that, there we are, we'll carry on. So hopefully you used it as an opportunity to have a few kind of explorations of that. Some other common analyses that we might do at an undergraduate level within psychology certainly is a correlation, and that tests, are there a relationship between two variables? So one test that we might want to run is to ask, are older people more suspicious or cynical or see more corruption? So we want to look at the relationship between participants' age and their ratings of perceived corruption. So we see if older people generally provide higher ratings of corruption perceptions. So as you might expect from a correlation, we're starting off at regression and we're going to go for correlation matrix. So for those following via my voice, we've gone to analyses, regression, correlation matrix. And so it's very simple. You just copy across the variables that you're interested in. In this case, we're interested in age and we're interested in corruption total. And if you copy those variables across, very quickly you'll see rather than a positive relationship as hypothesized, we've got here a negative relationship of 0.119 and a p-value which is not statistically significant of 0.074. Again, you can choose to have options which don't require so many assumptions with, for example, Spearman's row, and you can ask for all the other sorts of information, for example, confidence intervals, which can be super useful too. One thing I particularly enjoy doing is reporting the looking at the plots associated with it and asking for both densities and statistics, and you see here lots of very useful information. So you can see, for example, our age distribution on the top left-hand side. So you can see here that the vast majority of our participants were in the traditional, typical student bracket of 18 to 22, with a few exceptions. And our corruption total score is roughly normally distributed with a peak at around 4 out of the 7-point Likert scale. Now, once we've visualized our data, what we can see very clearly is that there isn't really any relationship. A lot of the data is clustered around the 20s age group, which obviously then makes looking at relationships a little bit more complex. But you can see here there's a general trend downwards, but the confidence intervals, the potential ranges provided could actually be no such relationship. And again, that's reflected by both the weak effect size, so the Pearson's R, which is our effect size here, which is 0.1, which is very, very, very weak, and a non-significant p-value. So that was just a random example to explore our correlation function. We can do the same if we look at regression. So in this case, can we predict people's likelihood to sign the petition using age and condition? So perhaps I've been a bit mean here, and we should control for or acknowledge the fact that some differences may be due to condition. or differences in condition. So let's run a regression. So we do regression analyses. We do linear regression this time. So for those following by my voice, analyses, regression, linear regression. And what we're going to say is our dependent variable is, in this case, let's have a look at whether people sign the petition. So we're going to pop that in our dependent variable box. And we're going to have a look at age and perceptions of corruption into our factors box. So again, we have got, condition is what I meant. So we've got the top dependent variable petition. 1 is yes, I'll sign it. 2 is no, I will not. And our factors are age and condition. So do age and condition predict the likelihood of signing the petition? And what you can do underneath is you can add a variety of different kind of complexities to this. So for example, you can add a variety of stages if you want to do a stage-wise regression. You can change the reference points. You can ask for assumption checks, which are obviously super useful. In this case, I'm going to avoid that. You can ask for a variety of different fit indices, including if you are more kind of SEM type inclined, you can ask for the AIC, BIC, and Ramsey. I know it's not called the Ramsey, but it reminds me of Gordon Ramsay. And I typically look at and ask for, under model coefficients, I ask for the omnibus test, the ANOVA test. And so this will tell us information specific to each of those predictors. So we can see here that neither age nor condition was a statistically significant predictor of likelihood to sign the petition. And you can go and explore some of these different options and see what they provide you in terms of a variety of additional supplementary details that you might want to report for this. So that's regression. Again, super simple. Hopefully very, very, very intuitive. The next thing I want to run through is our second hypothesis, which is around mediation. So what we assumed, or what was hypothesized, was that the condition you're in, whether you have a high or low structure, informed your perceptions of corruption. So higher structure leading to higher perceptions of corruption, and that if you perceived higher levels of corruption, you would then be more likely to sign the petition. Hopefully makes sense if you follow the logic of that argument. So let's analyse that. Let's try and do that. Now, the first thing you want to do is to add a new module. So under the first coloured bar on the top right hand side, the plus sign, add new module, go to Jamovi library, and in here you will find a few numbers down, med-mod, and that's hopefully mediation and moderation. I've already got it installed, and you can see it looks exactly like 3 variables that have been pinned together. And so what we ask for is mediation. We're interested in the mediation model. And for those who are familiar with the process syntax and such for SPSS, this will be quite familiar. I quite like this in that it provides very clear instructions of what's TV, mediator, and predictor. So in this case, we want to have our petition as our dependent variable. So petition 1 is yes as our dependent variable. We want corruption as our mediator, so we put corruption total in the mediator box. And then we want as our predictor variable condition. And we try and copy that across to our predictor, and this time it says no. For those who might have observed it, you see that our variable of condition is actually written in text as high and low. And for the most count, that's absolutely fine. But for this analysis, we actually need to convert this variable into a numerical one, so it better is read by the system. So just pop the arrow to put that mediation box away for now, and let's go and have a look at our condition variable. So you can see if we double click on the header to our column, we can see it is called condition, and there are 2 levels, high and low. Obviously, we now want to change this to be 1 and 0 or something like that. So what we need to do is we need to go to our data tab at the top and convert. We need to transform, and we need to provide another title. So I'm going to say condition number. Our source variable is obviously condition, and we're going to transform. And all you need to do is click create new transform. And so what we're wanting to do is to transform high or low to be 1 and the other one to be 0. So in this case, click on the add button that says add recode condition. And so what we're saying is, if our variable says, if source equals, and then in 1 quote mark, high, and remember it's a capital because the data is capital, use 1. And if else, use 0, because it doesn't really matter. There's only 2 things it could be. So in this case, it can be high or it can be low. And you can see you can use this for example, recoding variables if you need to reverse code a questionnaire item or something like this. This is a very easy way of doing that. And then if you get rid of that, you should be able to see in your data file that you've got now 2 condition variables, one of which goes high, 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 low, and the one next to it which goes 1, 1, 1, 1, 1, 0. And so that suggests that if you want to eyeball the data just to make sure that it has worked properly, we've now turned it into a numerical value, which is fantastic because we can now run our analyses. So if you click on the mediation box that you started, that's currently empty, that just says mediation estimates, indirect, direct, and total, click back on that, and we can now put in our new variable, which is condition number, in our predictor box, and immediately you can see things have started to happen. Now, for those who do bootstrapping, there's the option to do so. It does sometimes take a minute or 2, so I'm not going to do that right now. But what I am going to encourage you to do is to look at the additional outputs of the path estimates. You can ask for an estimate plot if you like, but in particular the labels and the confidence intervals. And so when we have a look at this now, we can see that we have quite a lot of useful information and that they've labelled it so we can explain it to each other quite nicely. So we have, in essence, 3 pathways that we've tested. We've tested, does the condition impact perceptions of corruption, which is label A? Does corruption or perceptions of corruption lead to differences in whether people will sign the petition? And the more direct relationship, which is, does the condition impact the signing of the petition? When we go to our kind of effect sizes and our p-values, we can see here that the first relationship, A, is statistically significant. So, and this replicates or kind of reproduces what we found earlier, which is which condition you are in does impact your perceptions of corruption. So that's grand. Also below 0.05 is our next relationship, which is that our perceptions of corruption do tend to be able to predict to some extent whether people sign the petition or not. However, when we have a look at our other relationship, which is whether condition directly leads to the signing of the petition, we've found that that has not been statistically significant. So from this path estimate box, you'd suggest probably that the perceptions of corruption are the pathway by which hierarchical structures can sometimes be evaluated differently with respect to trust behaviours, in this case, signing a petition to recommend an ethical audit. And you can see some other similar information in terms of estimates of the direct and indirect effect represented up here. Of note, none of these are actually statistically significant, so obviously suggesting weak effects or otherwise. And indeed they are quite modest relationships. And so that tells us here we conclude there are non-significant direct and indirect relationships, but that 2 of the 3 individual relationships are in fact statistically significant, but modest. Okay, so that was our mediation model. Again, that's great. Now, this is the point at which I'm going to encourage you to have a further play around with jamovi. So I've got 3 bigger questions, I guess, to leave you with to try. So the first is to run a 3x2 ANOVA and to see whether sex, which is obviously male, female, and not one of those, and condition, which is high or low, so 3x2, interact to predict perceived corruption. And just a little handy note here that the module you might want to try is ANOVA. You can also run an exploratory factor analysis to see if the control variables, which were, so in addition to asking whether participants being asked whether individuals working at this fake organisation are corrupt, they were also asked, are these individuals capable and are they smart? And these were kind of control variables to see whether that might be in effect. So you can try that, and you can see the variables are labelled control_smart and control_capable. And so, do these 2 items form a distinct factor from the corruption questions? So corruption _Q1 to Q3. That might be a useful thing to test. And finally, you might want to run a chi-squared test to see if the frequencies observed for audits or petitions were different to those expected by chance. So 50-50 as to whether they will or won't sign the petition and recommend an audit. And for that, you might want to use the frequencies module. So I will encourage you to pause the video, and I will only very quickly run through these afterwards just to confirm. So please do take a minute to try and have an exploration of these different options, and come back when you're ready. Okay, so as promised, I'm going to very briefly show you how these things are done. So the first off, we asked for a 3x2 ANOVA to see whether sex and condition interact to predict perceived corruption. So in this case, we're interested in a traditional ANOVA. So we've clicked on the ANOVA module and then requested ANOVA. Our dependent variable here is corruption total. So we pop that across there as our dependent variable, and our fixed factors are sex and condition. So sex is at the bottom and condition is the second variable. And you can see already here it's calculated the individuals variables and also the interaction. And we can see here that the interaction is non-significant, so there's a p-value of 0.09. And again, you can ask for all the usual useful information around model fits and effect sizes and things there as well. So if you want to report those, which would be incredibly useful, you can see that the effect sizes are practically nothing. So that is ANOVA, very briefly. The next one is exploratory factor analysis. So we go back to factor and exploratory factor analysis, so the factor module, and then under data reduction we're interested in exploratory factor analysis. And then all we need to do is very, very simply copy across those 5 questions to the variables box. And you can see here already the exploratory factor analysis suggested that they probably are 2 separate factors, which is good. It suggests that participants didn't respond to all of these questions in the same way. And again, you can have a look at all the traditional options for EFA. So, for example, you wanted to see a scree plot to see, just plot the eigenvalues to see whether perhaps there might be different factor structures. You can observe that there. Very simple. And then finally, a chi-squared test to look at frequencies. So, in this case, you want to go to the frequencies module, and you want to go for contingency tables and independent samples, so the chi-squared test of association. and then it should hopefully be very simple. You just copy across the two variables of interest, so audit and petition, and you'll be able to see here in the contingency tables that there is results that you wouldn't expect if things were randomly allocated to a yes, I'll sign, or no, I won't sign, or yes, there should be an audit, or no, there shouldn't be an audit. So the chi-squared test is statistically significant, and we can see here the distribution of scores is perhaps slightly different to what we'd expect from chance. So there we are. That's it. That's all I intend to run through with you with Jamovi. Just a few kind of hints and tips. So if you right-click anything on the right-hand side of the screen, you can choose to delete, copy, or export, which can be incredibly useful for copying things straight into a Word file. You can save your file at any point, so you save everything you've done to the data and the analysis at the same time by saving. And the useful thing of this is that it can be shared with anybody at any time. If you spot an issue with anything, you can change it whenever you like, and it will automatically update all the information on the right-hand side. And if you are attempting to engage with R, which is obviously much more complex and far less easy to explain in an hour and 12 minutes, you can ask for R syntax if you click the three white dots on the right-hand side. So where I changed everything from here, you can, for example, zoom in into your screen. So if you feel like you're doing demonstrations that might be useful, you can get closer and closer, and that's useful for sharing your screen. You can also look at syntax mode, and you can see here that you will be given information that can be run through R as well, which will reproduce the analyses presented here. So lots of options, lots of more complex ways in which you can kind of enrich your analyses using Jamovi. Finally, just a few hints as to where to go next if you want to build upon this. So the user manual is obviously super useful, and there have been a number of guides as to how to conduct some of these analyses. In particular, I like this online book, which takes you step by step through a lot of different individual analysis types. And Danielle Navarro's Learn Stats with Jamovi textbook is obviously brilliant. It's a free book. It's free online, so learnstatswithjamovi.com. If you want to read more about James's power analysis using JPower, the link here is on SciArchive, so it's sciarchive.com/bh8m9. And if you want to learn more about the project I've just walked you through, so my students' project on FAT and K, replicating studies 1C and 6, you can find everything in relation to this project on our OSF page, so osf.io/ZB5J2. So that is it for today. Thank you so much. I really hope this has been useful, just to get a sense of what's possible, how to negotiate some of the more interesting kind of dimensions of Jamovi, and to have a preview of running through some of the kind of undergraduate psychology curriculum of research methods using this approach. Obviously, if you have any questions, thoughts, ideas, suggestions, feel free to get in touch. thomas.evans@greenwich.ac.uk, or you can contact me through Twitter as well, @Thomas37. Thanks so much for joining me. I hope it helped, and take care.